Okay, so what we've got here is a situation where I've got a composite function. I've got the sine, and then I've got this inside function here, right here, right? That's an inside function. Here's the outside function. So I'm going to treat it that way. I'm going to treat it as if I'm going to just use a regular old chain rule. So I've got y equals sine of some inside function u, right? And yeah, I know it's not u. I know it's that inverse trig, and it might be hard to do. But we're going to take what we're going to do is just going to tackle it, just like a regular old sine function with a chain rule in it. So dy dx equals, and notice I am taking the derivative with respect to x, is the cosine of u, and then I got to take the derivative of u with respect to x. Okay, and now this is the problem right here. So what I'm going to do is I'm just going to go back and I'm going to do the substitution. I'm going to say u equals the arc cosine of t, which is just like what we've been doing. I'm going to take the cosine of both sides. That leaves me t. I can draw myself a triangle here. Adjacent side is 1, hypotenuse, adjacent side is t, hypotenuse is 1. 1 minus t squared, the square root of that, it's the opposite side. Let's take the derivative of both sides. So the derivative of cosine is the negative sine of u, du dt. I just see a mistake over here. I should be having this in terms of t. That in terms of t. I'll fix that in a minute. Equals the derivative of t is 1. And then I'm going to divide both sides by u, or negative sine u, equals 1 over negative sine of u, and so we know that's equal to the negative cosecant. So we've got the du dt equals the negative cosecant of u. Okay, so then I go back up to my triangle here, and I see the cosecant of u is 1 over the square root, mess. So negative 1 over the square root. Move down a little bit here. It's 1 over the square root of 1 minus t squared. Okay, and that's what du dt is. So back here in this function here, I'm just going to do some substitution. I know that I know u equals, my original u here was the arc cosine of t. So on this part, I'm going to write cosine of the arc cosine of t. That's what the u is, right? And then I'm going to multiply by the derivative du dt, which I just found out was that. And then the cosine of the arc cosine, those are inverse relationships. I'm just going to cancel them out. So that gives me t times negative 1 over the square root of 1 minus t squared, which is negative t over the square root of 1 minus t squared. I did check this on Wolfram, and they agreed. Okay, and that's how you do that problem.